When I was just a little boy, when I used the toilet, my mother taught me to wash my hands. And when I flushed and I looked at what was going down, I go, boy, you better wash your hands, you know? And I had this little puppy, you know, this little dog. And when I saw what came out of his body, and if I stepped in it, I go, boy, I better wash my hands. And my mother taught me all about germs and how bad they were, and you should always wash your hands. And I believed her. And then I grew up and I went to medical school, and we had the microscope. And we looked at these bacteria, and we heard these stories about how they cause these epidemics and people dying all over the place. And then antibiotics came aboard, and now we could actually stamp out these epidemics of these bad germs. And then, all of a sudden, I started hearing about the good bugs. And I go, what's that? And as we begin to look at the actual genetics, this was the breakthrough that allowed us to actually understand our microbiome, particularly in our GI tract. Because when I was just looking at them through a microscope, it was very limiting. You could only see just certain kinds. But now that we could actually genetically look at this. This all started about 10 years ago, and many of you are familiar with this, when they started looking at the genetics of the human. What are the genes? How many genes? What are the genes that we have? Through incredible research, it became apparent that we actually had like 26,000 genes. And I thought, wow, that's really cool. And everybody was studying the genes, and this was really wonderful, until they started studying the genes of a rice plant. The rice plant had 46,000 genes. What's that? You know, I mean, we're only 26, and they're 46? And so this was very humbling to say that the rice plant was more sophisticated than humans. So then about 5 years ago, everybody got busy, and they started to do the genome of the bacteria that resides inside of our body. Guess how many genes there are there? 100,000 genes. And so we begin to look at, what are these bugs? Who are these? What are these? So there's like 100 trillion of them. When we think of cells of our body, our biome describes 90% of all the cells. We're only 10%. So we just heard how wonderful it is to look at the astronomy and be humbled. Well, I would suggest we probably just need to look inside of us and really get humble, because the other is way beyond this. So these genes are incredible. There's about 1,000 different varieties, and then when we look at the species and sort of like that, it's incredible how diverse this whole environment, this whole biome is, and it just resides in some just humble you and me. Well, okay, let's team up with our bugs. So we're 26,000 and they're 100,000. Wow. Now we can trump the rice plant. So we better stay joined with them. So we begin to do, what actually does this biome do for us? So we first think of fermentation. Talk about a microbrewery. You know, right here in our right colon, right here, these bugs are actually fermenting, because this does a lot of good things, and they produce about the equivalent of a can of beer every day. And oh, yeah, that's true. And so, of course, we handle it quite nicely and so on. We don't get tipsy with that much. And so in this process of fermentation, some very important things are created, and they're called short-chain fatty acids. These short-chain fatty acids are critical to our immune system. So if you breed a little mouse that has no biome, this little creature is very vulnerable to infections and so on. And so in many ways, this is quite dramatic. And we wonder, where does this biome come from? Because the little human, when he's just inside the uterus, he doesn't have a lot of bugs. This is kind of coming in question here like right now. But so far, we've always thought of it being kind of sterile inside there. But when this little child goes through the birth canal and is breastfed, that is where the microbiome starts. This is critical to the life of this child. And our C-section babies and our babies that don't get breastfed, this is very difficult. So now, in modern places and hospitals that understand this, if the little child has to be born by C-section, a vaginal swab is actually taken and placed in the child's face and mouth so that it can actually become a microbiome positive creature. Otherwise, the immune system would not develop. So this is very, very vital. So that's kind of the positive side of the fermentation. But there's a negative side to this, and this is where, remember all these cells, these thousands of different kinds of bacteria. Like most of life, it's about a balance. And when they are not balanced, we call it a dysbiosis. When that begins to happen, we find that it starts causing diseases. You know the word irritable bowel syndrome. Some of you may actually have it. You know, diarrhea, constipation, abdominal cramps, all these kind of things. You know about colitis. You've heard of people that have colitis. These kinds of things are when there is a dysbiosis. There's an imbalance between the good bugs and the bad bugs. Also, we're beginning to understand that a lot of what is called autoimmune diseases, such as rheumatoid arthritis, multiple sclerosis, these kind of things may indeed be associated with an imbalance in our microbiome. So another thing that our bugs do is they harvest calories. Now, if you're starving to death and you're having to eat a lot of grasses and grains and things that have a lot of fiber, your body can only absorb a certain number of calories. And we can't absorb normally any calories from fiber. Fiber just goes down to the biome. And the biome actually will harvest from the fiber, will actually harvest an extra 10 to 15% of the calories from that food we've eaten. This is how humanity has survived very, very severe circumstances. But just as there's a positive, there's also a negative. And we find when we look at this whole obese area, this people are overweight. Anybody have any deficit of calories? Lunch looked pretty good, didn't it? So we're not living in a cave anymore, and we're not starving. So this good thing can then become a bad thing, particularly if we tend towards these particular kind of bugs. They're called Firmicutes. It's a big family group, and they harvest extra calories. So when we actually look at the biome of people who are overweight or people who have diabetes, they tend to have a lot more of this Firmicutes family. Are you following me? Do you see where this is starting to lead? What if we begin to change the biome to a more balanced biome for people that were overweight? You know how this is going to go, don't you? And the studies are already being done in mice, but you know there's a lot to this. So this study came out about 2 years ago. It was a fascinating study because they took these skinny little mice and they just gave them an artificial sweetener. And sure enough, the little skinny mice became fat and became diabetic. So then the obvious scientific question is, did the artificial sweetener change the metabolism of this little mouse, or did it change the microbiome? Guess what? So they did this elegant study, if you think a fecal transplant is elegant, and they took other little skinny mice and they just did a fecal transplant from the heavy mouse that had diabetes, no artificial sweeteners, and that little thin mouse became obese and overweight and diabetic. So you begin to see how this science is beginning to progress. And a third area that I think is very critical is what we call the gut-brain axis. And when you look at animal studies, you can take, again, these little germ-free mice, and when they're born, they're kind of autistic. You know, they don't kind of hang out with their puppy brothers and sisters, and they don't eat well, and they don't do things well, and they're kind of autistic. But if you then transplant normal mouse biome into these little guys, they become normal. They just kind of hang out with each other and so on. You can see where this is going, can't you? And sure enough, it's already happening. So in Europe, there's some beautiful studies that are being done on humans. Here in America, there's some people that on the side are just giving probiotics. You know, probiotics have the microbiome in them, probiotic enemas to autistic children, and actually seeing some development. I have not seen good randomized controlled trials, but where there's a little smoke, there definitely can be some fire. Now, in the human studies, one of the things that we want to know, so we already know that the gut affects the brain. What we also want to know, does the brain affect the gut? And sure enough, when we find people that are under high stress, of course, nobody here in the audience, I'm sure, was high stress. You know, that must be someplace else. But under high stress, the biome actually changes. And what we find is that there's a breakdown. So inside the gut, there's a nice little layer of mucus. So you have all this bacteria, and here you have your gut wall. And then this first layer of mucus, there is no bacteria. It's a barrier. The next layer is another layer of mucus that does have bacteria in it, and under stress, those mucus layers begin to break down, and antigens from the bacteria actually penetrate into the muscle wall and therefore into our circulation. So this barrier is broken down. And there's a great deal of study that's going on now to even look at microbiome and Alzheimer's. Alzheimer's is now being called diabetes type 3. Because we know that those high insulin levels, those high sugar levels, all these things may well be contributing. So at first I thought, well, this is a little fringy. But when I begin to see that we have neuroscientists that have linked together, 30 neuroscientists in the Scientific American, just published an editorial saying we need to take another look at Alzheimer's disease in relationship to the biome. So let's kind of think about how we can feed this biome. What are the nutritional features that we can do to help our own biome? So first of all, we have the refined carbohydrates and the processed foods. You're probably aware that of the 600,000 foods that are manufactured in America today, 72% of them had added sugar. That did not happen by accident. Sugar is addicting. That processed food is beginning to actually alter our biome to make us less and less healthy. So obviously, I teach my patients to just, when they go to a grocery store, just shop around the periphery where they have real food. Well, at least except for the deli, maybe. But real food. Don't go into that sinister middle section unless you need toilet paper or something. But that's where the real food is there. Eat real food, because that's what our body is set up for. And then eating our vegetables, and a lot of the fermented vegetables, so your kimchi and your sauerkraut and your kefir and your yogurt, all of these natural biome foods should be part of our everyday diet. And when we think about eating some healthy fats like avocados and walnuts and these kind of things, that's very important to create a healthy biome. So, and the biome needs protein, so good quality protein can be a very important feature. Well, I like to think about the lifestyles in addition to nutrition that could help our biome. And believe it or not, our gut bugs have a circadian rhythm. They have a night and day rhythm just like we do. And there's scientists that are doing research on the circadian rhythms of bacteria. And so when you don't sleep, your bugs don't sleep. And they need sleep. So it's really important to have that kind of lifestyle where you get sleep. And believe it or not, exercise also stimulates a healthy balance of the microbiome. You begin to see a trend here, don't you? So then the one that I thought was just scary, horrible, is that our use in antibiotics in America, 70% of all the antibiotics that are used in America are used to feed the animals from which we get our eggs and milk and meat and so on. 70% of all, and why do they do that? Because you give antibiotics to an animal and it gets fat faster and it goes to market quicker. So 70%, ever wonder why we're getting more bacteria resistance? And think of all of you, you know, the first time you get a sniffle, you know, I got a cold, and, I got to get rid of this. I better call my doctor and ask for a Z-Pack or something, you know, quick, a Z-Pack. Every time you treat your viral infections with an antibiotic, as in bacterial, it changes your biome. So if you do need antibiotics, be sure and follow up with your probiotics, your kefir, your sauerkraut, your kimchi, whatever you prefer. You've got to repopulate your bowel if indeed you have to use antibiotics. So, gut bug cultivation. You know, we should start a primer on this. You know, there should be something like gut bugs for dummies or something like that, you know. So first of all, we have to respect them. You know, they're 90% of who we are, all of our cells. They're there. And certainly we want to take good care of them. We want to make sure that they get the proper sleep, the proper exercise. And if you have happy bugs, you're going to be a healthy person. Thank you very much.